Okay, functions with radicals, section 15.7, just kind of a quick little review and then we'll jump right into it. Let's kind of remember as I scroll down here what a function is actually. Give me 1 second. Okay, remember a function is a relation in which each domain element has exactly one corresponding range element. Let's remember what these are. 1 second here. There we are. Remember that the domain element is your x value, and your range element is your y value. As I scroll down here, let's kind of just remember what that means pictorially. I'm going to change the thickness here. Okay, let's draw a little graph. Remember, when we were studying functions, we have a graph like this. Okay, we have y, we have x. When something is a function, it can look like this. Okay, this is what it means where the relation in which each domain element has exactly one corresponding range element. Notice here on this graph that as this line moves, okay, the x value is constantly changing. Okay, now if I'd drawn a straight line, the x value would have constantly changed, but the y value could have stayed the same. That is fine with a function. We also want to look at it in terms of the vertical line test. Which you'll remember from, I believe, I want to say chapter 13, it may be 14, but probably 13, okay? Remember, you don't want to have something that crosses right here. So this is a function. Okay, so scrolling on down here, okay, domain and range. Okay, once again, just as a review, let's just look at another graph here. And let's have just a line that looks like, we'll use what we're using today. That is what a function will look like. Let's draw some lines here. Horrible lines. I'm not very good at this pad thingy. Okay, but the domain, remember, domain equals x values. So your domain is when you're traveling along this line, and you're going along here, where does this line start? Okay, and does it have a closed circle or open circle? Well, this one has a closed circle. So remember, domain is going to be from right here at -3 all the way to positive infinity. Okay, well, our range equals our y values. And for that, it's like you're climbing up. So we're going up, 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 up. And then whenever I get right here to, we'll call that -2, notice I start seeing this line and it's a closed circle. So from -2 to infinity, because notice this line's going to just gradually keep going up very slightly, but it will go up for infinity. So the range is also -2 to infinity. That's what this means. So let's go and put that in the notes right here. Once again, x values, y values. Okay, a radical function is a function in the form y equals the nth root of g of x in which the radicand contains a variable expression. Okay, the domain of such a function depends on the index n. Okay, if n is an even integer, the domain of all set of x is that g of x is greater than or equal to 0. Let's just kind of make that a little bit simpler. Let me get this a little bit smaller so you can kind of understand. What this is saying is whenever you have a function, okay, remember what a function is. Okay, we just talked about it. So let's look at, let me close this down right here. Here we are. We're going to have functions that look like this. Now they gave you one that looked like this. N G of X. Okay. That right there is just some stuff on the inside. Let's actually write this down, what you're actually going to see on your homework. You're going to see things that look like f of x equals, let's make it 2x plus 3. Okay. Remember with a function is instead of me just having a y here, which is, remember from class, and is the same thing. I'm plugging into x, I'm going to get a y. Well, whenever you have this, when a function says, give me any x, and I'll give you any y, this makes this easier to graph. But just like with a fraction, we have a domain that we have to worry about here. So the domain, let's see here, domain of even radicals is, okay, for this, they have to be, I'll just put it this way, even x has to be greater than or equal to 0. Okay, so when we're solving for these, we have to make sure that whatever x value we have, when we plug it into this whole expression here, the whole expression has to be greater than or equal to 0. Okay, this you'll see more with examples as we go through. Well, let's see what else we got. Radical function, the range depends on the index n. If n is an even number, the range is the set of all real numbers greater than or equal to 0. We just said that. If n is an odd number, the range is a set of all real numbers. That's because of the way the graph looks. Okay, you'll see that, and then whenever we kind of start working through some examples. So yeah, that's about it. Let's do some examples.